is software bus networking, which is what you guys, so how many folks here are familiar with software bus networking? About half the crowd, that's good. Let's see if this works. It works, oh my God. So a little bit of history, I've been on this, I've been kind of the Stucky maintainer for SBN for the last year and a quarter, year and a half now, which I guess makes me an old timer. It was CFS is only 3 years old, so it's like, or well, CFS open source. So this is really an update from last year's presentation, which you can always get to if you really want to know what happened last year. But basically, SBN allows you to connect multiple software buses together using basically any protocol you want. We have some protocols already implemented, so if you just want to use TCP, UDP, or serial, or actually SpaceWire is not currently up to date, but we have SpaceWire. If you want to help me bring that up to date, we can do that. But basically, it allows you to, without having to do any configuration, besides where the other nodes are, you can connect multiple software buses together, and they'll share using the subscription model automatically. You don't have to configure all of your message IDs that you're sharing between nodes if you don't want to. You can if you want to. So SBN is an app within the CFS environment. So it sits alongside software bus, or it sits alongside limit checker and scheduler and all the other standard apps in your environment. But then it has a back-end dynamically loaded module architecture, so you can load different protocols on a back-end. Actually, one of the ones that folks might find interesting is we actually have I wrote a really dumb little DTN back-end, which actually necessitated some re-architecture of SBN because DTN is guaranteed delivery. JSC developed a TTE backend, which may necessitate further development because TTE has a totally different model from TCP, UDP, and DTN, but that's cool. I like that. We got that. So we've demonstrated SBN on a large number of nodes and a large number of peers all talking together using TTE, or JSC demonstrated that. I supported that demonstration. We've been, like I said, pushing different protocols, and part of that is pushing as much of the protocol stuff down into the protocol modules. So now basically all the management of the connection is handled at the protocol layer. We now support multi-task model, so you can have a task per peer and have it be more responsive, but then you have to manage your scheduler, your task scheduler properly. And just a lot of code cleanup. The code's been probably about 3/4 rewritten. And then brought some of the old modules and new modules up to date. And then also added runtime reconfiguration of remapping and filtering. So SBN by default, out of the box, will just share everything between all nodes that have connections. So if you have an app on one node and a publisher on the other node, they'll automatically start talking. You can, if you don't share message catalogs between them, you can remap them if you want to identify what the mappings are, or you can say I don't want to share those, or even flip it around and say I only want to share specific IDs. You can make it be an opt-in model. Just kind of showing the SBN model is one where you have networks of peers. You have multiple networks for each CPU. In this case, we have the CPU unnamed in the lower left that is talking to 2 different networks. And these could be, the netnum0 could be serial, and netnum1 could be UDP. Messages right now do not transit from one network to another. So messages published on the CPU from peer 1 do not go to peer 2 or peer 3. That's actually something that's to be researched, as well as routing and bridging between networks. But that's a dangerous space to get into. We have to be very careful what we do there. Let's see. So some future developments. Haven't really looked at the 6.6 APID impacts to SBN. Hopefully they're a week's worth of work. Knocking on wood. And then further EDS impacts, I think there's some interesting possibilities where then we can start getting into managing payload semantics. If you could have data type conversions or validations, things like that. I think also it's kind of what limit checker does right now, but or maybe integrate with limit checker and say, have a kind of a common model of how you handle payload data. Yes, sir.
On that note, people were talking about maybe doing some of the engineless conversions down there.
Or that, yeah, engineless conversions, packing, unpacking.
Right.
Yeah, all sorts of interesting possibilities, but right now it's just a thought bubble in my head. I still need to develop, to do unit test development for SBN if we want to release it as a certified product. Really, it's been kind of like, hey, does it run? Great. Command-driven reconfiguration networks. As we get into more of these swarms and complex systems of systems, manned vehicles, where you want to be able to runtime, add connections, delete connections that needs to be added. Right now, the network is text-driven, so I don't know that. There's a text file configuration file that really needs to be a table. So we need to. I've been kind of when people request a copy of it, because I kind of say, well, SBN 1.0 has been open sourced. I consider all the further development to be open sourced. It's been bug fixes, so but at some point it needs to be released publicly again. Which maybe I don't know if it would go into part of the apps package or a separate. And then JSC also is working on the SBN Lite, SBN Live releases. And then also JSC developed a prototype of a bridge, which I know that Beth was looking at kind of networking at one point. So I don't know. I dropped her a line, but I haven't heard back from her. But that may be something we want to look at as more of a unified activity. Then also, so the TTE SBN implementation uses a TTE library to bridge the SBN module, backend module, into the TTE network. Unluckily, Andrew Lovelace is not here to present on this. He wanted to be here, but he's had a conflict. But if people have questions about that, I can forward that on. And then this is more detail about the TTE network and and again, this is Andrew's slide, so I don't know a lot of detail about how this all connects together, but basically it's a library it's an SBN module that talks to a TTE library that talks to a TTE app that talks, et cetera, et cetera. So that's the SBN slides, but I actually have a second slide deck which is about voting, which gets back to SBN, so I'm going to cover that real quick. And if there's any questions about SBN or comments or concerns, go ahead. I'll repeat your question.
Yeah, you said not all the messages have to be relayed to all the nodes, correct? Figured that way?
Yeah, SBN has a remapping table, and in that remapping table, you basically say for this peer, remap this ID to ID 1 to ID 2, and if you say ID 2 is 0, it just says drop that message. Don't send that message to that peer.
So, but then they all have to be known at startup.
Well, there's one flag that's at the top level of the table. If you turn that flag on, the default is don't relay it unless it's in the table. So if you want to have it so that the default is you only send 2 or 3 message IDs between peers, you create a table that has those 2 or 3 message IDs, and you set that flag saying 1, saying by default drop it. If you see it in this table, send it. And then you just say the from and the to are the same ID, so that it goes across the wire and doesn't get remapped. So we can talk more. There's a runtime command control too, so you can at runtime commands update that table and that configuration. That's actually a new thing as of like a month ago. So
some of the reason for this remapping function is because we didn't have the extended namespace or namespace collision, and you don't want to have to recompile a node when you had some other node. So with the the extension, some of that feature needs to go away, but being able to filter is still useful.
Yeah.
And that's probably will be retained, but I guess a little bit of background for people who haven't used SBN is essentially it's a peer-to-peer with no plus master. So it shares the subscription tables between each of the application and startup. So a processor can go down and all the other nodes will unsubscribe to everything that processor subscribed to, that node subscribed to. And then when it boots back up, it'll resubscribe and reconnect. And it could be a completely different software load on that now. It'll just reconnect.
And re-update all the subscription
All the
tables.
peers will get updated because all the old ones were dropped and the new ones are added. So it's very dynamic. And that was one of the intended use cases, a dynamic environment. Even for fault tolerance, you can bring up a redundant node or not, and those kind of things. But there's a lot of new features in this. I know I wrote the original in 2004, so we can blame all the crappy software for a big chunk of it because it was a prototype for fun.
Yeah.
To do a demonstration. But there's a lot of features in it.
Go ahead.
Is there a plan to have peer-to-peer communication?
Yeah.
That's what there's currently. So there's.
But then if a node is down, then could you not pass information to another peer?
So there's no relaying. So I guess what you're asking is there a relay, is like a stored forward or a.
Right.
Yeah. No. There's thoughts of having those sorts of capabilities, but yeah, there's a company down the street from my office called Cisco that they had this whole architecture and have handled all these problems. And I know it's not as it sounds simple, but I know that routing can be really dangerous if you don't configure it right and you don't design it right. So, but it is on the radar for next year. I think is routing and bridging and really for store and forward, you probably want to use DTN and use the DTN's store and forward architecture and just. You just say when you come up, hey, here's my subscriptions. Whenever you show up, send me yours, and we'll play. So I just wanted to very quickly talk about our voting app that we developed. So we were running on redundant boards that were talking TTE. We call this the level 1 voter because we thought that we basically termed the TTE voting as level 0. And we have a diagnostic engine or 2 diagnostic engines that were running on the 3 computers simultaneously doing the same diagnoses. And so we wanted to vote the results of those diagnoses. So L1V is the name of the acronym. The level 1 voter is the name of the application that I wrote. And it basically subscribes to a number of message IDs. And then when it's woken up, it looks at its pipe and says, do I see the messages that I'm expecting from the 3 to be voted on or 4, however many CPUs, and if so, I'm going to vote on them. I'm going to do usually a bitwise comparison of these 3 or 4 messages, and if I get enough that I've got a majority, then I say, hey, I've got a majority. I publish a message out saying here's the result of the vote. Or if there's nodes missing or I didn't get a majority, I'll send out events saying there's something wrong. It actually supports multiple different algorithms. It's actually compile time. So if you want to do it, it doesn't do dynamic loading, but I didn't think it was really needed. But again, it just takes multiple messages, performs a function on them, and generates a result. Runtime reconfigurable as well, so you can change the behavior. We did a demo where we switched from majority vote to priority vote. So if you had a failover model, you switch to the priority vote. And then in order to test that, I developed what I called the Duplicator, but we nicknamed it the Mangulator because we wanted to have it actually manipulate and inject errors into the duplicate messages. So it looks for a message ID, and when it sees it, it sends out a duplicate message with a different ID or a modified one. So in this case, I have message ID 1234 that Duplicator is looking for, and when it sees it, it sends out 1235. Maybe multiple times. In this case, it's generating an error as well. And this is actually a UI. If you want to see it on my laptop, it's a little web UI timeline. And in this case, the duplicator's listening on the local bus, and it's listening for, these are just simple sequence IDs. So it's 1, 2, 3, 4, 5, forever. A little app that I wrote that just generates a single integer. And so it sees, on the left here, time 10, it sees the message that contains the payload 15 and duplicates it twice, but in the second instance, for the message ID 0890, the message is mangulated. It's basically just bit splatted to change that value. And you can also see there's little boxes that represent the commands that are driving the count app, which is just the one that does the count up and the duplicator. And then this is also doing SBN commands, but there's no SBN network in this slide. And then this is just showing how I'm combining the duplicator and the voter. So the duplicator generates the duplicates, and the voter votes on the duplicates the duplicator just made. And in this case, I have, and again on my laptop, 2 CPUs talking over SBN, the duplicator running on one, the voter on the other. And in this case, we're showing 0888, 0889, 0890 are the 3 to be voted, and 0891 is the resulting vote. So in the case of 23 there on the left-hand side, we have 3 that are voted on, and the result is 23. And the next one, 24, 24, 82. The third one is again, manipulated, but it is ignored because it's voted out. So, and that's my slides. So.
What is the status of the voter?
The voter is I would say it's beta. I mean, I'm happy to share it with folks, except for right now we haven't open sourced it. It's probably, I mean, the code-wise, it's 2,000 lines of code. It's really simple. Same with the duplicator. They're both very, very simple apps. So, you know, but I hope to open source it nonetheless. I think it'd be useful to generalize it for other environments. Any other questions? Good.
Yeah, you had a question mark. Is it SourceForge or GitHub now?
It's beyond my pay grade, but I think that's one of the things we're going to do as a board is look at what makes the most sense longer term. Historically, obviously, we've done SourceForge. GitHub, I think, gives us some advantages, but it also gives us some disadvantages in that it seems there's certainly a perception of loss of control, and certainly when you're dealing with flight software, with certified software, you want to make sure that people are aware of what is the official release, what is the controlled release, and all that. So I think that us as a board will decide that in the next release, but I think for 6.6 we're sticking with SourceForge as the official platform. As far as my apps, I probably put them on GitHub, but I don't see as standalone releases. Not a lot of point in integrating them into the standard apps build. So unless other people object and want to include it. So, but I think we'll be in further discussion on that.
Yeah, and I think James is still here, Mark. He's way back in the corner. So he's assembled a GitHub repository with all the open source apps just as a convenient way to downlink, and they all compile and build together. So that's, in terms of making the distribution easier than SourceForge, but hopefully they have more distribution.
Yeah, we don't. Part of the trick is if someone does a push to GitHub, we don't have a pipeline to get it back into our local GitHub. And really the nice thing would be is if we could either directly use GitHub from at some point, just switch over whole hog, or have synchronization between GitHub and our internal Git repository. I'm getting stuck with the Git repository, so at Ames. So and I know about much of Git so far, and doing that sort of synchronization between servers is something for me to learn.